NASA's tracking data just revealed something that shouldn't be possible. An object speeding through our solar system is changing direction, not because of gravity, not because of sunlight, but something else entirely. The numbers don't lie, yet no known force can explain what's happening. Some scientists call it a glitch. Others think it's a clue. But by the end of this video, you'll see why 3I Atlas has everyone questioning what's real.
It all started when NASA's Jet Propulsion Laboratory noticed something odd in their tracking data. An object labeled 3I Atlas, the third confirmed visitor from beyond our solar system, wasn't where it was supposed to be. At first, the difference looked tiny. According to NASA's calculations, the object was only a few arcseconds off its predicted path. But when you're dealing with something more than 200 million kilometers from the sun, that's not a rounding error, that's massive. The data showed 3I Atlas was accelerating, not spinning faster, not changing orbit because of gravity. It was actually picking up speed in a direction gravity couldn't explain. The shift measured about 0.002 millimeters per second squared. That sounds microscopic, but in deep space, even the smallest force applied over time changes everything. In just a single month, that minuscule acceleration nudged the object roughly 80,000 kilometers off course. And the direction of that motion? Not just one way. 3I Atlas was moving away from the sun and sideways at the same time, a pattern that didn't match any known natural behavior. NASA double-checked the numbers. The calculations were solid. The instruments were fine. There was no software glitch, no simple explanation. That's when the debate started. Was this just another case of outgassing, ice turning to vapor and giving the comet a small push? Or was it something else entirely? Because if that simple explanation didn't hold up, it meant one thing. Either there's a force in play we don't understand, or 3I Atlas isn't as natural as it looks. And what scientists found next only deepened the mystery.
So what exactly does it mean when scientists say an object is accelerating in a non-gravitational way? Think of it like this. If you throw a ball, gravity decides where it goes. The path is predictable. But if that ball suddenly had tiny thrusters firing on one side, it wouldn't follow that clean curve anymore. It would drift, twist, or speed up unexpectedly. That's what's happening with 3I Atlas. Every object in space feels gravity, but 3I Atlas is behaving as if it has an extra push coming from somewhere. The most common explanation for this kind of motion is called outgassing. It's what happens when a comet gets close to the sun and the heat starts turning its icy surface into gas. That gas bursts out like microscopic rocket exhaust, giving the comet a small boost and knocking it slightly off its normal path. This is a normal, well-understood process. Astronomers have watched it for centuries. So when NASA noticed 3I Atlas moving in strange ways, outgassing was the first guess. Logical, simple, easy to model. But here's the problem. The math doesn't fit. The amount of acceleration observed is way too high for the usual amount of gas a comet could release. If 3I Atlas were really being pushed by evaporating ice, it would have to be blasting out so much material that telescopes should see an enormous glowing cloud surrounding it. Yet there's nothing. No visible tail, no haze, no evidence of that supposed jet stream. So the question becomes, if it's not outgassing, what is it? Could it be rotating unevenly? Could radiation from the sun be nudging it somehow? Each idea sounds possible until you run the numbers. None of them create enough force. Something else is behind this motion. And when one Harvard astrophysicist ran the calculations, what he found pushed this story from strange to almost unbelievable.
When scientists realized the standard outgassing explanation didn't fit, one astrophysicist decided to crunch the numbers himself. Avi Loeb started with what we know. 3I Atlas weighs at least 33 billion tons. That's not a pebble drifting through space. It's a small mountain traveling at incredible speed. To make something that massive accelerate the way NASA observed, you'd need an enormous push. So Loeb calculated how much gas would have to be released to produce that acceleration, assuming the most optimistic scenario for a natural comet. The answer stunned even him. For the observed motion to make sense, 3I Atlas would need to eject about 1/6 of its entire mass during the few weeks around its closest approach to the Sun. That means over 5 billion tons of gas would have to blast into space, forming a gigantic, luminous cloud that no telescope could miss. The James Webb Space Telescope, Hubble, and multiple ground-based observatories have already been monitoring 3I Atlas. If that gas cloud existed, it would light up like a beacon. But so far, nothing. No bright plume, no halo, no visual trace of the violent outgassing the equations demand. And that's where the numbers stop making sense. If the acceleration isn't coming from natural outgassing, yet it's clearly there, something else must be causing it. Loeb pointed out that this isn't the first time an interstellar object has broken the rules. The first one, Oumuamua, showed nearly identical behavior, a mysterious acceleration with no visible tail or debris. Scientists were forced to label it a dark comet, a phrase that really doesn't mean anything. It's just a way to say, we don't know what this is. Now 3I Atlas is repeating the same impossible pattern. And if it's not gas, dust, or sunlight pushing it, then what is? By this point, scientists had ruled out every obvious explanation. The numbers were solid, the instruments were fine, yet 3I Atlas kept drifting in ways no natural body should. And that's where the conversation started to change. Instead of asking how it was moving, researchers began asking why. Why would two different interstellar visitors, first Oumuamua, now 3I Atlas, show the same strange acceleration with no clear physical cause? Could this be a repeating pattern rather than an isolated glitch in the data? Some scientists suggested 3I Atlas might be made of a material we've never encountered before, something that reacts to sunlight or cosmic radiation in unpredictable ways. Maybe it's porous, maybe its surface reflects light unevenly, creating tiny but constant pushes. Others wondered if it could be hollow, like a shell or a fragment from a much larger structure that broke apart somewhere beyond our system. That's where Dr. Avi Loeb re-entered the discussion. He pointed out that nature rarely repeats an anomaly so precisely. Two separate interstellar objects showing the same unexplained acceleration can't easily be coincidence. To him, that meant one of two things. Either we've discovered a new type of interstellar phenomenon, or we're looking at evidence of design. Not necessarily a spacecraft or a signal, but perhaps the remains of something once engineered. Debris from technology that's long since stopped functioning, drifting between the stars for millions of years. The idea split the astronomy world. Some called it bold, others called it reckless, but no one could deny that 3I Atlas forced a question. If natural explanations keep failing, maybe it's time to expand what natural even means. Because whether it's a new kind of cosmic material or a fragment of something artificial, 3I Atlas is telling us that the universe still has surprises we're not ready for, and this might be one of them.
Just when astronomers thought the mystery of 3I Atlas couldn't get stranger, it did. Because beyond its unexplained acceleration, the way this object looks makes even less sense. As 3I Atlas moved closer to the Sun, it began to brighten, which is normal for comets. Heat causes ice to vaporize, sunlight reflects off the gas and dust, and the object glows more intensely. But the way 3I Atlas brightened didn't match any known pattern. Instead of following the typical curve seen in ordinary comets, its brightness shot up at more than twice the expected rate. In numbers, that means while most comets get brighter following a power law of about -2 to -3, 3I Atlas followed one closer to -7.5. That's not just an outlier, it's a complete anomaly. Something about its surface or composition is reacting to sunlight in a way we've never observed before. Then came the color problem. Normally, as comets heat up, their dust scatters sunlight, making them appear slightly redder. Cold, dusty surfaces don't shine blue. It's simply not how physics works. But 3I Atlas broke that rule too. As it approached the Sun, its light turned blue, and not just faintly, bluer than the Sun itself.
That shouldn't be possible. Blue light usually means extreme heat or specific ionized gases, the kind produced in plasma or engineered light sources, not natural dust clouds. Some scientists propose that maybe carbon dioxide or another gas was being ionized and glowing blue. Possible? Sure, but the amount needed would be enormous. And again, telescopes would see it. They don't. So, now we have an object that's accelerating without gas, brightening faster than physics predicts, and glowing the wrong color entirely. Each anomaly makes the comet theory weaker and the mystery deeper. Because if 3I Atlas isn't reacting like any comet we've ever seen, then maybe it isn't one.
Whenever something defies explanation, science faces a choice: rewrite the theory or ignore the data. And that's exactly where 3I Atlas has forced astronomers to stand. For most researchers, the idea that an interstellar object might be artificial sounds too extreme. It feels unscientific, even reckless. So instead of exploring that possibility, many prefer to stretch the existing models, trying to make gravity, radiation, or outgassing somehow fit, even when the math keeps saying otherwise. But Dr. Avi Loeb has a different approach. His argument is simple. You don't get to reject data just because it's inconvenient. Loeb believes science only progresses when it confronts anomalies head-on, not when it dismisses them to protect what's comfortable. As he's put it in past interviews, when the evidence doesn't fit the theory, it's the theory that needs to change, not the evidence. That view has made him a controversial figure. Some scientists see him as bold and open-minded. Others think he's undermining the field by inviting speculation that sounds too close to science fiction. But for Loeb, this debate isn't about aliens. It's about intellectual honesty. If an object like 3I Atlas behaves in ways we can't explain, pretending it's ordinary doesn't make it so. Even those who disagree with Loeb admit that 3I Atlas is testing the limits of what we know. Its acceleration, its brightness, its color, none of it matches the textbooks. A few astronomers have quietly acknowledged that whatever the explanation turns out to be, it will likely reveal something new about physics, materials, or cosmic dynamics. And that's the real turning point here. Whether 3I Atlas is a natural phenomenon we've never seen before or evidence of something far stranger, the scientific world can't look away anymore. Because sometimes the most uncomfortable questions are the ones that move us forward.
3I Atlas has turned into one of the biggest mysteries modern astronomy has faced. It doesn't behave like a comet, it doesn't follow gravitational rules, and none of the standard explanations fit. Every new observation makes it more confusing and more interesting. NASA's confirmed that the acceleration is real, but without a visible gas cloud, without debris, and with a color and brightness that make no sense, scientists are running out of natural options. Right now, there are two main camps. One believes 3I Atlas is made of something unusual, a natural material that reacts to sunlight in ways we haven't seen before. The other thinks it could be something else entirely, maybe an artificial object, built or altered long before it ever reached our solar system. The real answers are coming soon. Between December 2025 and January 2026, the James Webb Space Telescope, Hubble, and several observatories will be tracking 3I Atlas during its closest approach. Those observations will reveal whether there's a massive gas cloud hidden from view, or if the comet theory finally collapses. And here's what I want to ask you. If 3I Atlas turns out to be something artificial, how do you think the world should react? Should scientists make it public immediately, or would that discovery be too big to reveal all at once? Let me know your thoughts in the comments. I'd love to see what you think. So if you want to stay up to date on what NASA finds next, make sure to subscribe, turn on notifications, and leave your comment below. Thanks for watching, and I'll see you in the next video.